Hello, this is section 8.3 counting. We have a tree diagram to using the probability. So the tree diagram, suppose the quiz has only two questions, and the first is a multiple choices question with the four choices A, B, C, D. And then each of the question has true or false, and then there'll be eight of the total the samples you can get. And then tree diagram is a systematic way of the listing every possibility. We can see that there are 8 ways to answer the test. So there are the ATAF, BTBF, CTCF, DTDF. Okay, so like ATAF, BTBF, CTCF, and DTDF. Okay, so CF indicates the quiz answer C, and then the first question and after second questions. So fundamental counting principle. So when you have an event 1, 2, 3 through the n as a sequence of n independent event, and if the event ek can occur the nk ways, and then k is 1 through the n, and then you just need to multiply those out as a numbers, and then that will be the n events to occur. And then these events must be the independent each other. All right, so let's take a look at the example to see what we can do. All right, so the first problem. An exam contains 5 true-false questions and 4 multiple choice of the questions. And each multiple choice of questions has 4 possible answers. And so which means there are 2 questions. There are 5 true or false questions, which is 5 true or false means you have choose of the 2 choices first and 2 choice for the second, 2 choice for the third, fourth, and fifth. After that, there are 4 multiple choice questions, and then each of the multiple choice question there are 4 possible answers. Okay, so each question has 4 possible answers, but there are 4 questions. Okay. And then if you do together, it becomes 2 to the 5th times 4 fourth power becomes 8,192. Number 2, suppose our license plate has a 2 uppercase letter followed by the 4 digits. So there are 6 places you fill it in. And then the first one, you have to do 2 uppercases. Uppercase, which means there are 26 of the alphabets, right? And then after that, and you can use the any one digit, which is 0 to 9, right? And here, so which makes what 26 squared times 10 to the 4, and then which makes it as 676,000, right? So which means 6,760,000 ways. Okay. Alrighty, permutation. A permutation is no order, an arrangement. For example, suppose that the 3 students are scheduled to give speeches in a class. Different arrangement in which these speeches can be ordered are called the permutations. Okay. So there are 7. How many 7-digit phone number are possible if the first digit must be 3 or 4 or 5? Okay, so 7 digits. So 1, 2, 3, 4, 5, 6, 7. But first digit has to be 3 or 4 or 5. So there are 3 choices. But other places you can choose any choices of 1 digit or 0 through the 9. Okay. And then you get the 3 times of, and then 10 has 6 power, which makes 3 million ways. So there are 3 million ways you can write it. Calculate 7 factorial by hand. So meaning of the factorial, okay, means you start from the 7 and then decreasing the number by 1. And then you can just multiply them together. So that's what we call the factorial. But also, we have factorial buttons on your calculator, so you can just do that too. All right, permutation of the n elements taking r at a time. So if the p of nr denotes the number of the permutation of the n elements taking r at a time, with r is always less than n, then we got the kind of form. Okay, so calculation is n is a 6, r is a 3. So it's same as 6 factorial over 6 minus 3 factorial. So 6 factorial over 3 factorial. Of course, you can use a calculator, but 6 factorial means 6 times 5 times 4 times 3 factorial. And then I just keep the 3 factorial because the 3 factorial is at the factor form. And then you just need to multiply 6 times 5 times 4, which is a 120. And then the 50 and 2 as a permutation means 50 factorial. And then you have 50 minus 2 factorial, which is same as 50 factorial over 48 factorial, which means 50 times 49 times 48 factorial over 48 factorial. Cancel. And then it becomes 2450. All right, now the problem number 6. For a class of 40 students, how many of arrangements are there in which 3 students each give a speech? So each student is different students, okay? So order the importance of permutation, 40, but you only choose 3 from there, okay? Which means 40 factorial and 40 minus 3 factorial, which is 40 factorial over 37 factorial. Use a calculator, you got 59,280. Alrighty, number 7. Now from here, count the possible ways that the 3 people can have a different birthday. Okay, so how many days a year? Which is 365 as a normally, right? But sometimes you have every 4 years you might have 366 days. Okay, so some people has a birthday on the February 29th, right? So I want to use 3 days, but 3 people has a different birthday, so it's be 3 from that day. So everybody has different. So 366 factorial over 366 subtract 3 factorial. You got 366 factorial over 363 factorial. And use a calculator. That'll be 48,620,760. All right, let's look at the next problem. Now the combination. So combination is different from the permutation. So order is not that important. The order is not that important. So the example, suppose that we want to select the tennis team of the 2 players from the 4 people, which is, it doesn't really matter which been picked, okay? So that's we use combination. So combination order is actually this one, okay? So you have less possible ways, okay? So which means you got a factorial over a minus 6 factorial and 6 factorial. So when you do this, you got a factorial, 2 factorial, 6 factorial. But make sure you need to put that thing in the parentheses in calculator, okay? So then you got 28. 40 factorial, 40 minus 2 factorial. So far this is a permutation, right? But also 2 factorial make the combinations, which is a 48 factorial, 38 factorial, 2 factorial. You got 788. All right, next problem. Okay, a student has 6 courses left in her major and plan to take 3 of them this semester. Assume that the student has a prerequisite for all 6 courses. Determine how many ways these 3 courses can be selected. There are 6 courses. It doesn't matter about order. So 6 factorial, 6 minus 3 factorial, divided by another 3 factorial. You should get 20. Alright, to play a lottery game, a person picks 5 numbers from the 1 through 39, then selects one more number from 1 to 19. So count the way that to play the games. Okay, so one of the way is, there's a 39 number, but he can choose a 5 number, which means 39 factorial, and 39 minus 5 factorial. 5 factorial, which is I got 575,757. But and also from here, also need to select a 1 number from the 19. So there are 19 ways you can choose, right? So multiply, you got the 10,939,383. Okay, so which means we can put this together. So it's C of 39 and 5. And then he need to choose 19. 1 number from the 19. And that must be the same number. How many committees of the 3 people can be selected from the 5 women and 4 men if a committee must include at least 1 woman? Which means 1 woman means, okay, so total of the number, which is 5 women, but at least 1 means there should be a 1 woman at least, right? And then 2 people from the man, which is a 4. And also, what if he choose 2 women from the 5? And then that means 1 person from the man. And then what if he choose all 3 women from the man, which means he choose none of them from the man, okay? And if you do that, this becomes 5 times 6, 10 times 4, 10 times 1, which is 30 plus 40 plus 10, which equal to 80. But there's another way. What if you only choose you're choosing 3 people and from the total of the 9 people, but you're only gonna choose the 3 people from the man, which means other place is gonna be just so it become 84 minus 4, same as 82. So either way is fine. All right, that's all. Thank you for listening.